This is the same image we looked at to start the Inner Planets lecture. It bears repeating simply because it illustrates that one of the major differences between the inner terrestrial planets and the outer gas and ice giants is size. Here you see the outer planets plus Pluto. We'll get to Pluto in the next lecture on solar system debris. The outer planets are often called gas giants, principally because they have extremely deep atmospheres due to their strong gravitational pull. They probably have a solid core somewhere below, but those cores have never been directly observed or measured. Notice just how much Uranus is tilted, over 90 degrees, so that it looks like it's rolling rather than spinning. This is probably as a result of a massive collision. Pluto has a similar tilt. You can see that each of the outer planets has a magnetic field similar to that of Earth. The magnetic fields of Jupiter and Saturn are similar to that of Earth, but much stronger. Notice that Uranus and Neptune have magnetic fields, but they don't line up very symmetrically to their axis of rotation. Jupiter is an enormous planet. Here you see the banding structures in the atmosphere. If you Google an animation of Jupiter, you'll see that some of those stripes travel to the left while other bands travel to the right. You can also see the shadow of a moon passing over the giant planet. Earth's moon is pretty large. It's smaller than Earth, but it's enormous if you compare it relative to Jupiter. Jupiter's moons are dwarfed by the size of their parent planet. Here is an image of Jupiter and its great red spot as taken from the Voyager spacecraft. Jupiter is made primarily of hydrogen and helium like the Sun. Jupiter, though, is much less massive than the Sun and is not capable of igniting like the Sun did. The current moon total is, at the time of this recording, 79, having been recently increased due to the defining of the orbits of additional objects. This number will continue to change over time as new objects are discovered. Jupiter is so large that 11 Earths could fit across its diameter. It is 300 times more massive than the Earth, and you would weigh more than twice as much on Jupiter as you do on Earth. There's a relationship between a planet's mass and its radius that determines the gravitational pull you feel on a planet. Even so, remember that Jupiter is a gas giant, so even though we can measure what you would feel as weight on that planet, you couldn't walk around on it. You'd simply begin falling through the gas until you were crushed by the pressure of the atmosphere on top of you. Jupiter is basically a space vacuum. We here on Earth may owe our existence to massive Jupiter protecting us from rogue bodies flying through the solar system. In this image, can you see the 4 dark spots in a line across Jupiter? These marks resulted from a comet that flew too close to Jupiter. The giant planet's gravity pulled the comet apart, and as each piece was drawn in, it punched holes into Jupiter's clouds. It's noteworthy that every planet we've discussed so far has experienced impacts. Accretion is a dangerous process, and it continues to this day. Earth and Mars were whacked so hard they got moons. Venus was hit so hard she spins backwards. And Mercury was hit so hard he lost most of his crust and mantle. Jupiter is still being impacted in modern times. One of Jupiter's most obvious features is a hurricane-like storm called the Great Red Spot. It's called that, well, because it's a spot that's large and red. It's currently about 2 times the size of Earth, but it is shrinking. Not that long ago, it was closer to 3 times the size of Earth. The storm is rather unlike a hurricane, though, since hurricanes normally last for less than a couple of weeks. This storm has been raging on Jupiter for over 400 years. Smaller storms like these often combine to form bigger storms, sometimes even changing color as different types of materials are churned up from below. Here you see the stripes or belts of Jupiter. These stripes are caused by Jupiter's strong winds and fast rotation. Earth has similar wind patterns, but we don't see them as clearly since Earth's atmosphere is much thinner and it rotates more slowly. It takes 24 hours for Earth to rotate once, but giant Jupiter does it in only 10 hours. Here you can see an image of Jupiter's ring. It can only be seen when the spacecraft photographing it is behind Jupiter and the Sun is hidden behind the planet. You can see how thin the ring is compared to the large planet. Here you can see a cross-section of Jupiter's rings and 4 moons that orbit within it. Here, 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 and here. Galileo was a probe that was dropped into Jupiter years ago to take measurements of Jupiter's atmosphere. Currently in orbit around Jupiter is a solar-powered spacecraft called Juno. We're unsure how long Juno will last, as its orbit takes it dangerously close to Jupiter and in a very strong part of Jupiter's magnetic field during part of its orbit. Here are some recent photos taken by Juno. The first image shows one of the polar areas, and the other images show the roiling clouds in the middle latitudes. These images, taken with a different instrument on Juno, show many strange spinning storms interacting with one another. Both of the Voyager spacecraft launched in 1977 visited Jupiter. Voyager 1 went past both Jupiter and Saturn. Voyager 2 flew past all 4 of the outer planets. Both spacecraft are far out beyond most of the Kuiper Belt where Pluto lives, and are beyond the area where the Sun's gravitational effect influences them. Voyager 1 is about 157 AUs from the Sun, while Voyager 2 is 130 AUs from the Sun at the time of this recording. As a comparison, Pluto is only 40 AUs from the Sun. The link at the bottom will show you updated versions of these numbers if you wish to check it out. Remember we talked in the first unit about Galileo Galilei and that one of his major discoveries was 4 moons of Jupiter. Though we now know about 80 moons around Jupiter, the 4 Galilean moons remain the largest. They are pictured in order from Ganymede on the left to Callisto to Io and to Europa on the right. Let's take a closer look at each of these moons. Jupiter's Io is the most volcanically active body in the solar system. You can see it casting a shadow on Jupiter in the first image. In the second image, you can see the pockmarks of the individual volcanoes. In the lower image, you can see just how big Jupiter is compared to this tiny moon. Io's volcanoes don't work the same way Earth's do. Earth volcanoes are as a result of plate tectonic processes. Io is much smaller than Earth, and it should have cooled much more rapidly than Earth and should have no plate tectonics today. However, its close proximity to giant Jupiter means that the large planet is continually pulling on Io gravitationally, squishing it like a ball of Play-Doh. Jupiter's gravity pulls on Io's rock the same way our moon pulls on our oceans to create the tides. This keeps Io melted in the interior so that it can continue erupting long past the time when it should have cooled. Europa may be the most exciting moon of Jupiter. Although it looks mostly like a snow or ice ball, it is so much more. Here, you can see lots of cracks that have formed in Europa's frozen surface. These cracks and ridges are faults. They prove that below Europa's frozen crust, there is an ocean of water moving that comes up to freeze when the cracks form. Could there be alien life in the ocean inside that moon? We don't know, and it's not likely that there are Europan fish swimming around inside that moon, though it is possible that there's bacterial life somewhere within that water. Ganymede is Jupiter's largest moon and is in fact the largest moon in the solar system. Here, see it with Jupiter. Though it looks incredibly small next to Jupiter, this moon is actually bigger than the planet Mercury and is almost as big as the planet Mars. Ganymede is mainly rock and ice with small amounts of other materials. It is large enough to have an atmosphere, and there is a small amount of oxygen in that atmosphere. It also has a significant number of craters that are relatively easy to spot in the color-enhanced photo on the right. Finally, Callisto is the moon that looks the most beaten up by impacts. It is also likely made of ice in the whiter areas and dark rock in the more shaded areas. Even though it looks like it has a relatively dark surface, it actually is more reflective than our own moon. An upcoming mission from the European Space Agency called JUICE will explore these moons of Jupiter, collecting information that may help us determine whether any of these moons are habitable. Jupiter's symbol looks like a curly 4 or a 2 crossed with a 1. Jupiter is the head of the Roman gods. Zeus is his Greek equivalent. He's the most important god in both mythologies, so it is fitting that he shares his name with the most massive planet. Saturn is the planet with the most extensive ring system, though all 4 of the outer planets have rings. Here, you see an image where the Sun must be off to the right. The lit half of Saturn is to the right, and the planet is casting a shadow over the part of the rings that lies to the left. Saturn, like Jupiter, has only a 10-hour day. Because of this fast rotation, both planets are oblate, or fatter across the equatorial diameter than through the polar diameter. Here, you can see several pictures of Saturn and its rings. At different times during Saturn's year, you can see the rings at different angles. Sometimes they are easily seen as they are in the top image. At other times, they are more edge-on and appear much thinner. Also like Jupiter, Saturn is composed mainly of hydrogen and helium, the 2 lightest elements. Saturn, though, is less dense than Jupiter. In fact, its density is so low that if there were a bathtub big enough, Saturn would float in it. Saturn also has nitrogen and also some oxygen in its atmosphere. It has over 80 confirmed moons. Notice here that the south pole of Saturn is darker than the northern half. Saturn is a large planet, but its rings make it even wider. The image you see is to scale. If you could pick up Saturn and move it to our part of the solar system, Saturn would take up almost all the space between Earth and the Moon, though it would wreak havoc on our ocean tides. Both of the Voyager probes launched in 1977 passed by Saturn, and the Cassini mission, launched in 1997, had Saturn as its target. The Cassini mission recently ended in September of 2017. Cassini's job was not only to study Saturn itself, but also its rings and moons. One moon, Enceladus, was found to have geysers erupting water into space from its surface. It must have a subsurface ocean, much like Jupiter's moon Europa. Cassini also observed wave action in Saturn's ring particles as moons revolved around the planet, and even found what appear to be lakes on Saturn's largest moon, Titan. Jupiter has the Great Red Spot, and Saturn has even stranger-looking storms. Located at the poles, these strange whirling storms circle the polar areas. The one at the North Pole is shaped like a hexagon. Also around Saturn's poles, aurora are often seen. Earth has aurora, or northern and southern lights like this, caused by sunlight interacting with the planet's atmosphere. Earth and all 4 gas giants have aurora, but the other inner planets do not. In order for a planet to have aurora, it must have both a magnetic field and an atmosphere. Earth and all 4 gas giants have both. Mercury has a magnetic field but lacks an atmosphere. Venus has an atmosphere but lacks a magnetic field due to her slow rotation. Mars has very little atmosphere and barely any magnetic field at all. Here is a close-up image of Saturn's rings taken by Cassini. The rings are made of boulder-sized chunks of rock down to sand-sized grains of rock and ice. The ice is highly reflective, and that's why Saturn's rings are so easily visible from Earth, even from such a great distance away. The rings are incredibly thin, and the pieces of material in the rings are constantly moving, disrupted by both Saturn's gravity and that of several moons that orbit within the rings. Here, you see a cross-section of the rings. Different parts of the rings are named by capital letters, named in order of when they were first discovered. A ring was discovered first, followed by B ring, etc. In the lower image, you can see the same thing from a different angle. Notice the gaps you see between some of the rings. There are moons that orbit within these gaps. The largest gap, called the Cassini division, is named for the astronomer that discovered it. The Cassini spacecraft was also named for him. Titan is Saturn's largest moon. It's the second largest moon in our solar system, smaller only than Ganymede, and has a thick nitrogen atmosphere, much like Earth. The atmosphere also contains a lot of methane, natural gas, or CH4. Earth has a water cycle, but Titan is too cold to support liquid water. Instead, it has a methane cycle, with what appear to be methane lakes on the surface and methane as vapor in the atmosphere. Titan is the only moon, other than our own moon, that has been landed upon. The Cassini orbiter had a probe called the Huygens that was dropped onto Titan. As it was coming down, the picture on the right was taken. These dark spots are most likely lakes of liquid methane. Though methane is a gas on Earth, Titan is so cold that the methane would naturally be a liquid. The picture on the left is of Titan's surface, taken after the Huygens landed. The small pebbles seen in the foreground are only a few inches across. Here, you see an image of what appear to be volcanoes erupting from the surface of tiny moon Enceladus. Instead of erupting lava, however, these are cryovolcanoes, spewing out water and other compounds that immediately turn to ice crystals. These ice crystals feed the highly reflective material into Saturn's ring system. Some of the particles contain salt as well, meaning that the subsurface ocean may be similar to Earth's oceans. We don't know whether there might be organisms living in this ocean below Enceladus's icy surface. These geysers occur only in Enceladus's southern hemisphere in the area called the Tiger Stripes. Thermal images taken by Cassini indicate that this area of the moon is considerably warmer than the rest of the moon's surface. In these areas, either the ocean is closer to the moon's surface, or perhaps the ocean only exists under this part of the moon. The ocean is likely kept liquid rather than being frozen, either by radioactive decay of elements within the moon or by similar tidal heating processes that keeps Jupiter's moon Io volcanic. This ocean appears to have all the compounds known to be needed for life and an energy source, so perhaps there are microbes living inside this tiny moon. Saturn's moons have a variety of appearances. Iapetus appears to be covered with snow. Hyperion is heavily cratered, and Mimas looks a lot like the Death Star. Mimas creates the Cassini division gap, and another gap called the Encke gap is formed by the moon Pan. This image shows a size scale model of the moons in the top image. Notice how much larger Titan is as compared to the rest of the moons. The lower image shows Saturn and its moons to scale by distance. Notice the lists and arrows to the left, indicating that those moons don't fit on the screen on this scale. Saturn is Jupiter's father. He was the Roman god of agriculture. Kronos is his Greek counterpart. His symbol looks like a curvy lowercase h with a line through it. Here is aqua-colored Uranus and one of its moons, Ariel. Yes, you pronounce it Uranus, not Uranus. Uranus, along with Neptune, is considered an ice giant, though both are also considered gas giants. Notice how large they are compared to Earth. Though both of these planets are made of materials that would be gases on Earth, they are so cold because they're so far away from the sun that they are probably more like a slushy, icy consistency rather than true balls of gas. Like Jupiter and Saturn, Uranus is mostly hydrogen and helium, but its bluish-green color comes from methane found in its atmosphere. Uranus is nearly featureless, meaning that it doesn't have the storms, stripes, and cloud formations also often seen on the other gas giants. Its tilt is so extreme, over 90 degrees, that it looks like it somersaults rather than spins. It takes 84 years for the planet to revolve around the sun, meaning that each season is 21 years long. If you're about 21 years old, then that means that you're only one season old on Uranus. If you'd been born on the first day of winter, it would still be winter. Here you see also Uranus's rings. They appear vertical rather than horizontal due to the extreme tilt of the rotational axis.
It is likely that Uranus is sideways because it was hit by something early on in its formation that knocked it sideways.
There are 11 rings around Uranus, but they are extremely thin and very dark. That means they are very difficult to see, and we are unable to see the rings from Earth. Here you see several of Uranus's moons. They revolve in the same direction as the ring system. The largest of the 27 moons are shown, each named for a Shakespearean character. Uranus was the first planet found in modern times. 1781 might not seem modern, but the other planets we've discussed already were known to ancient people. Uranus is so distant that it couldn't be discovered until after the invention of the telescope. It was discovered by an astronomer named William Herschel, who worked for King George. Herschel wanted to name the planet George in his honor, but that name was rejected. Wouldn't it be weird to have Mercury, Venus, Earth, Mars, Jupiter, Saturn, and George? Here are Uranus's 5 largest moons. They're all pretty similar in color and reflectivity. They're all heavily cratered, showing signs of ancient impacts from the formation of the solar system. These are the same 5 moons to scale. Titania is the largest, with Oberon only slightly smaller. Miranda is the smallest of the 5. Some of Uranus's moons are called shepherd moons, meaning that they act like sheepdogs controlling a herd of sheep. They keep the ring particles orbiting along the same path. Here you see 2 of them controlling the thickness of the ring between them. Here is Uranus, Greek god of the sky. His symbol is an arrow pointing up to the sky with a dot in the center of the circle. His other hand was accidentally broken off his statue. His name, in Roman mythology, is Caelus. And the final major planet in our solar system is Neptune. Neptune is very similar to Uranus in size, but it's slightly more blue. It often shows streaks of white clouds and darker stormy areas. Here you see an image of Neptune's rings. They are very dark and reflect very little light. They can only be seen from behind the planet when the brightness from both the sun and the planet are blacked out. Neptune was actually predicted to exist before it was discovered. Remember, Uranus had been discovered in 1781, and over the years, people were studying Uranus and its orbit. It was discovered that Uranus was not traveling as quickly as it ought to, meaning that something large must be out there beyond Uranus affecting its orbital rate. In 1846, calculations were done to determine where and how big this object had to be, and it was found just a few months later.
Similar to Uranus, Neptune is mostly hydrogen and helium with some methane that makes it blue. Although Uranus is rather featureless due to chemical reactions that create haze in its atmosphere, Neptune doesn't have this. As it's 30 AUs away from the Sun, Neptune is 30 times farther from the Sun than Earth. So the chemical reactions that cause the haze on Uranus aren't present at Neptune, so we see more features in the clouds. Neptune is so far away from the Sun that it takes 165 years for it to complete its orbit around the Sun. In 2011, we celebrated the 165th anniversary of Neptune's discovery, meaning that we've only known about Neptune for just over 1 Neptunian year.
While Neptune is the outer planet, Pluto is beyond it, well, usually. Pluto's orbital period is 248 Earth years, but its orbit is more elliptical than Neptune's. So for 20 years out of its 248-year period, it's actually closer to the Sun than Neptune. And though their orbits cross, Pluto and Neptune will never collide. They are in a 2 to 3 resonance, and that means for every 2 times that Pluto orbits the Sun, Neptune goes around 3 times. So they will never be at the same place at the same time.
Much like Jupiter's great red spot, Neptune had a great dark spot. This hurricane-like storm was about the size of Earth. Jupiter's spot has existed for over 400 years, but Neptune's spots come and go, forming and later dissipating. Neptune is a very stormy place, mostly due to the fact that it has winds that blow up to 1,600 miles per hour. You couldn't walk on Neptune, not only because it's made of gas, but also because you couldn't stand up in the strong winds.
Here is another image of the Great Dark Spot on the left. In the image on the right, the Great Dark Spot is the largest spot on the left, and a smaller spot called Scooter is below it. And even farther south is another dark spot called Dark Spot 2. Each storm on Neptune travels at different speeds, so though they were close together at the time of this image, they wouldn't always be so. Here's an image of Neptune's rings. They may have formed from a moon that was torn apart, meaning that these rings may not last very long as compared to the age of the solar system.
Neptune's largest moon is called Triton. It is the only large body in the solar system that orbits in a retrograde direction. Recall that Venus rotates in the opposite direction, but she revolves around the Sun in the proper direction. The fact that Triton orbits backwards means it probably did not form with the rest of Neptune's moons, but was probably captured by the planet later. It probably originated in the Kuiper Belt where Pluto lives and wandered too close to Neptune, getting caught in Neptune's gravitational field.
Neptune is the Roman god of the sea. Poseidon is the Greek version. The planet's symbol is the trident, a 3-pronged spear that he carries.